Okay, so good morning, everyone. Thank you so much for joining us today. I'm really excited for our speaker today, and it's not very often where I get to be sitting in the same room with our speaker, but he's right over there. So it's kind of a fun day today for me. So for respect for our speaker, I will remind you to please keep your microphones and your videos turned off during the actual presentation, um, so we can make sure that he has the full floor to himself. And otherwise, just a little bit of upkeep. We do have our next two speakers planned. Our next speaker is going to be another one of our GBATnet students. So you can be on the lookout for Andrea giving her talk, which she has yet to send me the title for, but it's going to be good. She does some really brilliant work. So stay tuned for an announcement for our next speaker. And then our July speaker is going to be Dr. Jerry Carter, and he will be talking about social interactions with vampire bats and social interactions with bats in general. So be on the lookout for those talks. Otherwise, I am very excited to introduce today's speaker, the newly minted Dr. Reed Crawford, who is going to be speaking to us today about bat box research and a global review of that. So without further ado, I'm going to go ahead and pass off. So Susan says, congrats.
Thank you.
So without further ado, I will pass off literally the microphone to Reed.
All right. Oh, good. All right. Feedback's gone. Cool. Yeah. So thanks everybody for tuning in. And yeah, so today I'm going to be talking to you about a global review of bat box research here today, covering a broad variety of topics and things like that. Obviously, I won't be able to hit on everything there is out there, as the body of literature is pretty big. But yeah, hopefully I'll find this information pretty useful. Let's see if I can get it to go forward now. There we go. So yeah, a little bit about me before we get into this here. So yeah, like Dana mentioned, I just finished my PhD in ecology, evolution, and conservation biology at the University of Illinois at Urbana-Champaign. I studied mostly bats and artificial roosts, so looking at thermoregulation and artificial roosts, looking at roost selection, primarily working with the endangered Indiana bat and some work with the Florida bonneted bat. Before that, I did my master's degree at Eastern Kentucky University, focusing on the artificial roost selection of Indiana bats in Indiana and central Kentucky, as well as looking at the microclimates of different artificial roosts and how that impacted roost selection. And then way back, you got to go back to 2018 when I graduated. I got my bachelor's in biology at Indiana State University. That's actually where I started my first job volunteering in Dr. Joy O'Keefe's lab, doing artificial roost research at the Indianapolis airport. So Joy and I have been working together for about 9 years on bat box research. She's been involved with basically every project I've been doing work on there. So yeah, 9 years of work with bat boxes up to this point. Hopefully a few more years after that. But yeah, first getting into this talk, I wanted to talk about what are bat boxes. So a lot of you are probably familiar with these things. They're all over the place. But essentially, I define artificial roosts or bat boxes as purpose-built structures intended to provide bats with either day roosting habitat or maternity habitat, or potentially night roosts in some cases for bat species all over the planet. And artificial roosts come in a variety of different shapes and sizes. So we have these single chamber flat facing bat boxes, which are super common. We have these more multifaceted structures, rocket boxes, bark mimics, and things like that offer roosting space in all sorts of different directions. We have much larger structures like bat condos and things like that all get lumped together in this category of artificial roosts. And these things, as you can see, are made of a variety of different materials, oftentimes wood, woodcrete, concrete, and some plastics and things of that nature. And they can range in price from about 20 to 30 US dollars up to tens of thousands of dollars, potentially, if you're putting in one of those really big bat condo structures. So all over the place in terms of what you can spend on these types of structures. And bat boxes are used by tons of bat species globally. So the previous review that looked at this, they found about 70 bat species. That was about back in 2016 by Ruger from Australia. But since then, there's probably been a lot more bat species that have started taking up residence in artificial roosts. There are likely to be more bats to start using bat boxes as they become more common globally. But for the most part, it's a lot of insectivorous bats, and that probably represents a research bias. But there also are a bunch of frugivorous and nectivorous bats that do use different types of artificial roosts out there. So me personally, I've built lots of artificial roosts for bats for my master's and PhD research. I primarily work with these rocket box style artificial roosts, which you can see represented in a variety of photos here. I've probably built and deployed somewhere around 100 of those rocket boxes during my graduate career, and focusing on a variety of different styles and manipulating the temperature profiles we're offering to bats. And I've also built some of those more traditional flat face style artificial roosts as well, which you can see up there in the top right. For Florida bonneted bats specifically in that case. And subsequently, I've deployed these artificial roosts all over the eastern United States, so places like central Indiana, central Kentucky, way up in northern Minnesota, and way down in the southern tip of Florida, down near Fort Myers for those bonneted bats. So we've worked with a variety of bat species all over the eastern United States. And our lab also has a web page, which I've linked down below there, where we've collated a lot of information about making bat boxers safer for bats in terms of their temperature profiles and things of that nature. So trying to compile some of that scientific literature and synthesize that to a certain degree for the general public there to look at. So yeah, getting into the history of bat box research just a little bit here. So bat box research has been going on for a very long time, so dating back to as early as the 1950s. But most of our really rigorous bat box research didn't start taking off till the 1990s and early 2000s. But you can see most of this work has been biased towards Europe for the most part, and then we're starting to get more contributions from North America and Australia. This graph ends in about 2014, which there has been a substantial uptick in artificial roost research since then, but not much representation from Asia, South America, or Africa at this point, though there are a couple papers from Africa now that have come out more recently. And you can look at also the type of research that people are doing with artificial roosts. So a lot of this is actually just research focused, so trying to answer questions about what bats are doing, where they're going, what they find attractive. But a lot of this is also conservation focused, so trying to either facilitate exclusions of bats from buildings, offset habitat loss, and things of that nature. So there has been some research focus there as well. And the other special thing about artificial roosts is they can be used for community outreach, though that's not necessarily represented in this graph here, as a lot of that type of work does not get published. But I wanted to talk a little bit about the methodologies that we use for studying bats in artificial roosts. And oftentimes they're very, very simple. One of the basic things that I do a lot of is spotlight checks, which you can see in that central photo there. Just taking a bright spotlight and going up underneath your artificial roost and briefly shining it into that structure just to see if there are bats present in there. It takes a couple seconds to get an idea if there are bats hanging out in that roost. And one of the other prominent things we do after we've done spotlight checks is figure out where we think the most bats are and do an emergence count at sunset to try to get an idea of what the colony size or group size of bats using that roost is. And I've got a quick example video here on the right. So that should show you hopefully some bats flying around these two rocket box style artificial roosts. So typically setting up at sunset. This actually shows just a lot of roost checking behavior. The bats are already out in the landscape flying around, and they're just coming to check out these different roosts to see if their friends are hanging out there. So no one's really emerging here, but it's kind of a cool little video there. But one of the last basic methods that we use for monitoring artificial roosts is looking at guano detection. So this is a really great passive way to monitor if bats are using your artificial roost structures or if they're potentially using those as night roosts and you don't actually see them there during the day. Oftentimes we'll deploy things like guano traps, which you can see in that photo in the bottom left. And that's essentially, I've just built a PVC frame and thrown some screen around it to catch the guano as it falls out of that artificial roost. And also these can function as pup catchers as well. So catching pups that get dislodged from that roost and fall down. And we've actually made some little pieces of bark that will attach to those poles to actually give that pup some place to tuck up underneath so it's not super exposed to birds and things like that if it does fall out. But the other methodologies that have become more prominent recently to study artificial roosts is the use of radio transmitters and temperature-sensitive radio telemetry. So I've done a lot of this with my PhD research, which will hopefully be published here in the near future, but we'll get to that at some point. But radio transmitters can be used to look at bat movement between different types of artificial roosts in response to things like weather and landscape placement and that sort of thing. But also something that's been super prominent in Europe for studying bats and artificial roosts is the use of pit tags or passive integrative transponders, where you can actually put a pit tag reader on your bat box and monitor bats as they come in and leave those roosts. You get really good timestamps and movement information from all sorts of different individuals. But from a lot of this early bat box research, we really started to figure out basic preferences for bats, what they find attractive, and how to get them to use artificial roosts. One of the main things we figured out over the years is that solar exposed bat boxes are generally pretty attractive for a variety of bat species. So many bats will actually preferentially select these sun-exposed bat boxes, and we think that's due to these warm roosts favoring pup development and reducing energy expenditure for those reproductive bats. So basically, if the roost is really warm, they don't have to rely on their metabolic heat production as intensely to maintain their body temperature, so they can save energy that way. And early on, for about the first week of a pup's development, it's basically pretty much dependent on its mom's body temperature to maintain its own body temperature. So if the pup is warmer, it can grow faster and has a higher probability of surviving winter. But one of the first studies to sort of talk about solar exposure as being important for bat boxes was Birmingham and Williams 2000. And this was sort of just an anecdotal observation. They didn't really test this super rigorously here in this study, but they were working with excluding big brown bats and little brown bats from buildings in northeastern United States. And they would put bat boxes up on the sides of these buildings in conjunction with those exclusions. And they actually had really high success getting bats to move into these artificial roosts. But one of the sort of anecdotes from that study is they found that more bats or these artificial roosts were more successful if they were getting more than 6 or 7 hours of sunlight here. So there's been a lot more research on solar exposure since then, but this was a pretty big deal finding that out because we have had studies in the past where people have put up potentially thousands of artificial roosts at some field sites. Like one of the ones I worked at in Indianapolis, they'd put up thousands of artificial roosts for Indiana bats, but they didn't know anything about the preferences for Indiana bats, and they put them all in the shade. And most of those artificial roosts, unfortunately, went unused at that point for about a decade before they figured things out. But we also found from a lot of this early research is that darker paint colors are generally attractive for a variety of bat species, and this also relates to temperature and energy expenditure. However, I'll note that dark paint colors can actually be a problem in a lot of cases when we think about overheating, which we'll get into later. But some of the first studies to really look at this, I'll point to Kurth et al. 2020 or 2001. So the Kurth lab does a lot of work with Bechstein's bats in Europe, and they've published tons and tons of research on artificial roosts with those few colonies of bats that they have out there. But essentially what they did was they had these paired deployments of white and black artificial roosts that they would put on trees, and they put those in a bunch of solar exposed and shaded locations. What they found out was these Bechstein's bats, these reproductive females, overwhelmingly preferred those black artificial roosts to the white ones, and overwhelmingly preferred those solar exposed locations as opposed to those shaded locations. So it really means that these bats are selecting these artificial roosts based on temperature, likely to be saving energy in that case. And we also had a more recent study. This took place in South Africa on the right, Weir et al. 2019, published in Peer J. And they worked with a variety of different bat species out there, so it's not specific to one bat species in general, but they also found this similar finding that these darker artificial roosts were more attractive in Africa for a variety of different bat species, so generally more successful than those lighter shaded artificial roosts. So bat box design can also be really important to consider when you're talking about improving the attractiveness of your artificial roost structures. So one study I like to talk about a lot is Ho et al. 2018. This took place in central Indiana, but she was working with artificial roosts in Indiana bats, and she had systematically tested 3 different designs of artificial roosts and found out that Indiana bats actually preferred the rocket box style, which was the largest artificial roost structure, and it also had a pretty diverse microclimate. So couldn't pin down specifically what they liked the most about that structure. It's probably a combination of factors, but that can actually substantially influence the success of those artificial roosts. So when some people put up artificial roosts, it can actually take years to get occupancy of those structures. But at the case of the Indianapolis airport, we have these bats' preferences figured out so well that we can deploy new artificial roosts and get bats to use those within the same month of deployment, which is pretty crazy. That actually happened this year with our master's student, Johnny, who just deployed a bunch of bat boxes out there and already has bats using them. So really cool stuff to see. But another example of this would be Ruger et al. 2020 in Australia, where he was testing a variety of plywood and woodcrete bat boxes. So in his case, I believe he was working with Gould's wattle bat, and he found that those bats actually preferred the larger plywood bat boxes over those smaller woodcrete bat boxes. And again, there was that paint color preference, preferring that darker shade of paint to the lighter color of paint there. So design is really important to consider when you're working with your bats, and that can be species specific to some degree. But another thing you can use bat boxes to do, besides just looking at general bat preferences for roosts, is use them to study the economic importance of bats. So looking at things like crop pest suppression, so reductions in crop damage, and also look at the diet composition of bats to see if they're eating those crop pests or disease vectors or something like that. They can also use bat boxes in some special cases to look at bats' ability to disperse seeds and look at reforestation. So one study I like to talk about related to looking at pest suppression would be the study by Puig Montserrat et al. 2015, published in Mammalian Biology. So this study, took place in Europe. And essentially they were working with a colony of soprano pipistrelles, I believe in this case. But they were working on this landscape with a bunch of rice paddies that were infested with this striped rice borer. And essentially, in 1999, they had a colony of about 243 bats on this landscape. They deployed a bunch of artificial roosts, and by 2008, they had a colony of about 3,500 bats on this landscape. So an order of magnitude change, which is pretty substantial in terms of how many bats were out foraging on this landscape. And what we're looking at here with this graph is the bat density on the left y-axis, and that's represented by those gray bars on this graph. So the bat density bats per hectare is increasing through time up to 12 individuals per hectare. And then that black line there represents the number of rice stems infested with this rice borer per meter squared. You can actually see that's decreasing through time as the number of bats on that landscape increases. So it's a really cool demonstration using artificial roosts of how bats can actually impact pest suppression. And I believe they put a value of about 21 euros per hectare for these bats or something like that. So you can actually put a valuation on this ecosystem service that bats are providing, which is really cool. Another thing you can use bat boxes to study is bat diet. So there's been a lot of work looking at bat diet and artificial roosts, or using our guano collected for artificial roosts. But essentially, with these bat boxes, you can get these really big colonies of bats. So you can get lots of individuals that are foraging all over these landscapes. You can put up really simple guano traps like I've got shown in this photo here, or you can lay something as simple as just a clean plastic tarp on the ground underneath that structure to collect guano. And you can see you can get lots of guano pretty quickly. So I was doing a lot of this work during my master's, and that would represent an accumulation of about 2 days of waiting in between when I would clean those guano traps out. So you can get lots of guano pretty quickly. You can look at things like the number of insects present within each of those guano pellets to get an idea of what pests they're eating, what disease vectors they're eating, and and get an idea of the relative abundance of those things in their diet. But another really cool extension of this work is you can potentially link some of this dietary work to bat health. So one of the postdocs in our lab, Andrew Bennett, just recently published this paper looking at the epidemiology of this Eimeria species, which is an endoparasite in the intestines of bats and a lot of other mammals. And he was actually using, in this case, collecting guano to look at dysbiosis in the gut microbiome of Indiana bats. So this is a really well-studied endoparasite, and you can infer inflammation and gut inflammation based on the dysbiosis that's present when you're looking at the composition of microbes in the gut of the Indiana bat. So potentially really cool stuff. You could use this with artificial roosts as well when you're collecting guano and look at potentially the health of species in different habitats and things of that nature, which is super cool. But bat boxes can also be used to study seed dispersal and reforestation in a lot of cases. So one study I'm pointing out here is Kelm et al. 2008. And this study actually took place in Costa Rica. So it was a fragmented landscape they were looking at. That photo on the left is in Costa Rica, but it's just an example of one of those landscapes similar to what they would be working in. But they had forest patches out on this landscape, and they had more open, fragmented, or disturbed pasture land. And out in those pasture lands, they deployed artificial roosts for frugivorous bats on this landscape. I believe they had several different species of frugivorous bats end up occupying those artificial roosts. But essentially, they looked at seed rain underneath those artificial roosts, compared that to a natural roost in an old forest, and then compared that to the background rate in these fragmented pasture lands out there. What we saw that seed rain was actually much higher underneath those artificial roosts compared to those empty places on the landscape where those bat boxes weren't placed. However, it was substantially lower than those natural roosts in the forest. But this gives you the idea that if you do deploy bat houses really far out on these fragmented landscapes, these bats could facilitate seed dispersal by eating those seeds from the forest and bringing them farther out away from those patches. So it's a really cool idea. It gives you some idea what other bats could be doing in the background that aren't using artificial roosts. So if they have isolated roost trees and things like that, they could be helping some of those tree species disperse farther out on the landscape, which is really interesting. But bat boxes can also be used to study social cues and behavior of bats, which is a really interesting use of artificial roosts. So you can ask questions like, do bats use roosts they're familiar with? or will they be pretty willing to use new novel roost structures? And are conspecific cues really important when they're looking at selecting an artificial roost? So one thing that's interesting to think about, and there hasn't been much work on this paper actually just got published this year, which is one of the first ones to look at olfactory cues really rigorously. But things like guano and urine can be important cues in indicating that a roost is either suitable or has been used by bats before. And this was actually done in the Kurth lab again in Europe, working with that colony of Bechstein's bats. But essentially what they did is they have this colony of Bechstein's bats where every individual is pit tagged. They know who that individual is, and all of their artificial roosts have these RFID antennas that can read those pit tags as the bats enter these artificial roosts. And basically, they put up these paired artificial roosts on the landscape with either feces from individuals from their own colony or feces from individuals from different colonies. And what they found out is that these bats preferentially colonize those new artificial roosts that had guano from members of their own colony in it. So it's an interesting scent cue that maybe they were interested in familiarity of individuals. And it's not necessarily just the presence of guano in the structure. It depends on, or it's important what individual bat that guano came from, or if they know those individuals and have information about them that could influence roost selection. So a huge potential to do a lot more work in this field, looking at scent cues and things of that nature, and understanding how bats are perceiving those cues and how that influences their roost selection. Another thing that's really important to think about is also acoustic cues. So looking at things like acoustic lures. So there hasn't been much done with artificial roosts and using acoustic lures. This is pretty big at looking at trying to increase mist net captures of bats by broadcasting an acoustic lure to try to attract them to your nets. But the other idea is you could actually put acoustic lures up near newly installed artificial roost clusters to try to facilitate bat investigation of that area and potentially colonization of those structures. So this was a project I actually did for some of my dissertation work down in southern Florida with the Florida bonneted bat. We actually put up 3 different artificial roost structures in a bunch of different locations on this landscape, but we offered them an artificial roost design that they were familiar with, and then 2 different rocket box style artificial roosts that they hadn't encountered before. We actually put up an acoustic lure and broadcasted pre-recorded Florida bonneted bat calls from an adjacent field site where those bats were using artificial roosts. So we had calls from bats exiting artificial roosts, approaching artificial roosts, foraging, and just a variety of social calls that we were broadcasting. And unfortunately, in our case, this lure actually didn't end up working out to bring bats into this landscape. We did get a harem colony of bonneted bats to form, but that happened actually 2 years after 2 years when our study had actually just finished. The bats actually started moving in, which was unfortunate. But with acoustic lures, there's a lot we need to figure out. So bat social calls are incredibly complex. We don't necessarily know what information we're broadcasting out there and what bats actually find to be important. There has been previous work with acoustic lures and bonneted bats to actually increase mist net captures of males, which is interesting. So we thought we might have a chance here, but we still need to learn more about these bats. So in the case of the Florida bonneted bat, they think it conforms to what they call resource defense polygyny, where the male selects a territory and he defends that territory, and females are choosing males based on the quality of that territory. So you might have cases where either a male is broadcasting aggressive calls, and that might actually deter bats from going to that location, or you might have a male singing to attract females, and maybe that brings bats into those locations. We really don't know what these bats would find important or what they deem important. And time of year can also be a very important thing to consider. When are bats actually searching actively on the landscape for new roosts, and when are they more settled down and not moving? And again, social structure is very important. So the bonneted bat, compared to a lot of temperate insectivorous bats, is very, very different in terms of what it's doing than little brown bats, Indiana bats, Bechstein's bats, those sorts of things. So other bat species are more matriarchal in their social structure. This one's a little bit different. And another thing you can look at doing with artificial roosts is looking at information transfer among bats. So there's a variety of different ways you can do this to get look at roost discovery and how bats are transferring that information. But one really cool study that was really early on looking at this was Kurth and Reichert 2003. So this was working with, again, that colony of Bechstein's bats in Europe. But essentially what they did here was they had paired artificial roosts, again, that they were deploying on the landscape. One of those artificial roosts had actually a barrier inside it, so the bats could land on the landing pad and crawl up in a little bit, but then they would hit that barrier and couldn't go into that roost. So they labeled this roost as the unsuitable roost in the cluster, and then one of those roosts was open and the bats could crawl all the way up in and actually use it. And since all of these individuals were pit tagged on the landscape, they could actually mark individuals that investigated these unsuitable roosts, and they would label those as experienced individuals. And then they would look at the proportion of naive individuals that would end up visiting those unsuitable artificial roosts. What they found out in this case was virtually most of the naive bats that didn't know about the suitability of those roosts would actually overwhelmingly end up in those suitable artificial roosts without ever having visited that unsuitable roost right next to it. So this indicated that some of those individuals that had experience with visiting that unsuitable roost communicated that information to the other individuals in their colony and ended up making a transfer to the suitable roost without ever having investigated that other structure. So really cool to think about. But there's a lot more work people could be doing here to figure out which individuals are making decisions in colonies about where to roost and where not to roost. Is it one individual? Is it multiple individuals? And how are they discovering these new roosts? So lots of different ways you could look at using artificial roosts to answer information about how bats are transferring information and making decisions. But another thing I wanted to talk about here was using bat boxes or improving bat boxes for conservation specifically. So a lot of our historical bat box research is focused on how do we get bats to use these artificial roosts, but not necessarily looking at how well are the bats doing in these structures. So one paper that my advisor Joy and I had published back in 2024 was titled Improving the Science and Practice of Using Artificial Roosts for Bats, where we talk about a variety of knowledge gaps with regards to how we're using artificial roosts and how we could potentially solve some of those issues. So one of the key things we point out is that there are very few measures of bat reproductive success and survival in artificial roosts. We have a good ideas that probably bats are doing well in some of these structures, but in other cases, they might not be doing well. And this could be species specific or landscape specific in terms of what's going on. So it's a big gap in our knowledge that we need to really understand. We also have a very poor understanding of bat physiology and energetics in artificial roosts. So the design and paint color of your artificial roost can influence energy expenditure, which could have long-term consequences for pup development and overwinter survival and things like that. So it's important to consider those things when we're building new artificial roost designs. We also note that there are problems with overheating in some instances, and this can relate to paint color and your climate and things of that nature, and also potential problems with ectoparasites, though there really hasn't been much work in this area just yet. And then also investigating the potential for behavioral change. So if you have a nomadic species like the Indiana bat that roosts in really ephemeral dead trees that don't last very long, what are the consequences of putting up a permanent structure that these bats are going to be using year after year after year that's not going away? And then lastly, one of the things that I'll talk about at the very end is the consequences of putting up bat boxes on degraded landscapes. So should you try to restore that landscape to some degree before you try to promote bats actually roosting on that landscape in terms of thinking about their health and reproductive success? But one thing, looking at energy expenditure, so there has been a little bit more work happening more recently on this, but you can actually use bat boxes to look at energy expenditure and potentially relating that to white nose syndrome and trying to improve outcomes of bats infected with white nose syndrome. So one really interesting study that sparked a lot of new research in our lab was by Wilcox and Willis 2016, where they were actually looking at using artificial roosts to reduce energy expenditure of white nose impacted bats. So from the work of Chang et al. 2018, we know that bats with larger fat stores may actually have better odds of surviving winter with white nose syndrome. So they have more fat to burn through. They can theoretically arouse more often if they're infected with this disease. And potentially improving summer roosting habitat could benefit those bats impacted by white nose syndrome if we could lower their energy expenditure and increase their fat stores going into winter. So essentially what Wilcox and Willis did in this study was they actually built some heated artificial roosts where they could maintain temperature within the bat's thermoneutral zone during the daytime, and then they would shut that off at night to allow that roost to cool down so that the bats could use torpor. And that first graph there at the top is showing you average daily energy expenditure over a range of dates there, several weeks. And they have two scenarios there that represent an attic scenario. I think they're specifically working with little brown bats in this case. You can see that energy expenditure in that heated artificial roost, which is scenarios 3 and 4, was substantially lower and actually really consistent. But they would actually save bats about 80% of their daily energy expenditure if they were in that heated artificial roost over that more attic situation where the temperature is much more variable and fluctuating. They also did a captive lab study where they had little brown bats infected with white nose syndrome, and they looked at and they offered those bats heated and unheated artificial roosts and look at the proportion of bats roosting in either of those options. And they did this for about 2 months, and they found that almost every single day those bats were selecting that heated artificial roost every day except for one day, which you can see on that bat, the proportion of bats in those heated roost structures. So there's a lot of potential here to try to improve our artificial roosts and decrease energy expenditure of bats. And this doesn't necessarily have to be through heating an artificial roost structure, right? This could be looking at adding insulation and heat capacity to the structure to try to retain heat in that roost. So you can also think about retaining the bat's body heat that it's generating and not necessarily capturing more heat from the sun. So finding ways to insulate our artificial roosts to improve outcomes for bats is a potential way to increase overwinter survival for some of our bats out there. Another thing that really hasn't been looked at much at all is ectoparasite loads. So our lab has been doing a little bit of work more recently looking at ectoparasites in artificial roosts, specifically bat bugs, this Chimex species. And one thing I want to point out is that these artificial roosts are permanent. We might not necessarily be cleaning them out or anything like that. And so you do have the potential to get lots of ectoparasites within those structures if you're forming really large colonies of bats in those roosts. So these are a couple photos from rocket box style artificial roosts that had been used by Indiana bats for 2 to 3 summers from about 2018 to 2020, 2021 in that area. And we took down all 18, or we took down about 30 artificial roosts across our field sites in Indiana and Kentucky, and we dissected those to look at ectoparasites. And we found that this was related to colony size. The larger colonies had more ectoparasites in those roost structures, but we found several artificial roosts with over 1,500 bat bugs within those structures, which is pretty crazy to think about. We would have colonies of 100 to 200 bats, and that ratio would almost be about, 10 to 20 bugs per bat. In some cases, which is pretty crazy because these parasites, if you're thinking about the size it would be to a human, it's almost like a golf ball, which is pretty nuts to think about. So, and this is a video of some of those bat bugs crawling around in there, but we have a variety of different life stages they're represented, which is pretty gross. But those bat bugs had survived all winter in those artificial roosts. So we took them down in January or February when we dissected these. So the bats hadn't been around since November in this case. So they'd gone 3-4 months without food and exposed to freezing temperatures. And as soon as they warmed up, they were just fine and good to go again. So pretty crazy to think about. And I think there needs to be a lot more research done on ectoparasites and bat bugs and things of that nature, because these could have serious consequences for the physiology of bats and energy expenditure, especially for our younger pups that can't groom themselves as well. So bat bugs are known to preferentially parasitize pups in a lot of these roosts. Another thing that I wanted to point out more recently is that bat deaths from overheating are becoming more common in the literature. So this is something we need to pay special attention to with the increasing risk of heat waves and overheating, or increasing intensity and frequency of heat waves due to climate change. So one of the first studies that I like to point out about this that actually shows a really big overheating event was Steve Griffith's paper from Australia, which was published in 2021. He documented the death of 30 large forest bat pups in a dark green artificial roost that was getting a lot of solar exposure. This roost, our outside air temperature reached about 37 degrees Celsius that day. They didn't have temperature monitoring in that roost, but it likely exceeded 40 degrees Celsius by quite a bit, and resulted in all 30 pups within that roost dying. And most of the adult individuals were showing signs of severe heat stress within that roosting structure. But we also have our overheating events in Europe and North America as well, especially one that occurred during my master's research where we actually had Indiana bats die from an overheating event during a pretty bad heat wave. So we had 11 pups, I think, die at one of our field sites. And a lot of those pups also had ectoparasites on them, which is pretty concerning. You could have a combination of factors leading to bats being more susceptible to heat if they're not in great condition from parasitism and things like that. But what temperatures are stressful to bats? So this is pretty important to know if we're going to address that issue of overheating in artificial roosts and bat boxes. But fortunately for us, we have a large body of literature on respirometry data relating bat metabolics to temperature, and specifically looking at where thermoregulatory failure occurs. We also have a handful of field observations of bat responses to heat in barns and in bat boxes. And what we know is that bats are generally trying to avoid temperatures when possible that are greater than 40 degrees Celsius by shifting their position vertically within those roosting structures if they can. Bats generally don't leave artificial roosts. There are some cases where they might if it gets too hot, but a lot of bats will sit there and bake essentially, and especially pups that can't move themselves around that well are particularly vulnerable to overheating. And most bat species are going to die within about an hour of exposure to 45 degrees Celsius. So that's something we want to try to avoid in our artificial roost if we can, or provide plenty of space down lower in the artificial roost if the top portion does get very hot in those structures. But in recent years, we've had an influx of research on microclimates and temperature profiles of artificial roosts, which has been really helpful in trying to understand what's going on and trying to improve these structures. So our lab at the University of Illinois here does lots of research with bat boxes and trying to improve their temperature profiles. I did a lot of research with that during my master's and my PhD, and we have a new master's student, Johnny Bachleny, who's going to also be doing a lot of work improving artificial roost designs in terms of their temperature profiles and energy expenditure. So just a little bit of information about what can be done to prevent artificial roost overheating. So choosing lighter paint colors can be beneficial. So some of our work suggests that if you're mixing black and white paints together, having that ratio of less than or equal to 40% black will reduce your overheating event quite substantially. However, if you do have a more insulated, larger artificial roost structure, you might be able to get away with a darker paint color. Some of our mathematical models we've been working with recently show that if you do have a lot of insulation in your structure, you might actually want to be painting it a darker color to increase that heat absorption. But if you have a smaller wooden bat box, dark paint colors are incredibly dangerous in that case. But one thing you can also do to decrease overheating risk is increase the heat capacity of that structure. So essentially just increasing the density or the amount of material that's there that the sun has to heat before that internal temperature increases. Our lab does this by adding water packets inside a sealed chamber in our artificial roost. So water has a very high heat capacity. It takes lots of energy to increase its temperature. So that's going to slow down how fast it's heating up and also slow down how fast it's cooling down at night. And the other thing about this is it's also going to protect bats from cold snaps. So for the roost temperature where the bats are to actually drop below freezing, all the water in those water packets that are surrounding them has to freeze first before that temperature actually drops. So that was the latent heat of fusion, I think. It releases some heat when water fuses into ice, which is pretty interesting. So another thing to think about is increasing the insulation in your artificial roost. So you can add insulating foam layers to your artificial roost, which can reduce the thermal conductance, so slows down how fast its heat is transferring to that internal structure. And if you combined the heat capacity with insulation, you actually get a much stronger effect with those two combined together. So a lot of our research is going to be focusing on that in the future. But there's a lot of potential here to really reduce the risk of overheating and also increase or decrease the energy expenditure of our bats. But also another thing is supplying larger artificial roost structures when possible. So especially if you're working with a species that forms really large colonies, providing them with ample space so that they can move is a good thing. So you might get into situations where you have a really tall artificial roost or something like that. You have a bunch of bats in it. The bats at the bottom of that artificial roost might be at an okay temperature, but the bats at the very top might actually be experiencing stressful temperatures and they can't actually move down to get away from that. And the bats at the bottom of that artificial roost have no real incentive to move because they're in a comfortable temperature. They don't want to get eaten by a predator if they leave that artificial roost. So big artificial roosts can be better in a lot of cases. But lastly, I want to get into talking about a little bit about what I see as some frontiers in artificial roost research, where I think more research is definitely needed and has a lot of possible avenues for people to get involved in that. And one of those things I think is that more microclimate research is needed. So there are hundreds of different artificial roost designs that people are using all over the world, and there's lots of different designs that are getting sold online. And most of those designs have had no essentially preliminary assessments of what temperatures they're offering to bats, which is kind of scary in a lot of cases. But studying artificial roost microclimates is actually pretty easy. So what our lab often does is use these little eye-button temperature sensors, which you can see they're represented in the top left photo. And we just attach those to dowel rods or lath and slide it up into an artificial roost. And you can get a vertical temperature profile within that structure. And then also you can set your data logger to record hourly, every 2 hours, every 30 minutes or whatever. And you get the temporal profile of that artificial roost. And then you can generate these really cool heat maps, which you see represented there on the right. And you can see where is this artificial roost getting too hot. When it does get really hot, are there suitable locations lower in the roost for those bats to retreat to? And you can also relate that to things like weather and look at heat retention overnight and things of that nature. So very simple to do. And you can also, when you collect these temperature data, since we have these really good respirometry studies out there that relate temperature to energy expenditure, you can use some really simple bioenergetic models to figure out what artificial roost is going to reduce energy expenditure for the bat species you're working with. Another really interesting thing to think about is how we're building artificial roosts. So I think there needs to be more innovation in terms of how developing new designs of artificial roosts that are going to be good for our bat species. And one thing you could do is spend a lot of time in the wood shop like I do, just building new different designs and things of that nature. But there are also other ways to do this that can be more efficient. So one example would be Parker et al. 2022, where they were looking at using augmented reality to design artificial roosts. In this case, they're working at recreating a natural burrow roost for an owl that they were working with. But you can actually design this in 3D space, then actually 3D print that structure, and you can do some or create something that really closely mimics a natural structure in terms of its architecture more easily than potentially building something out of wood to try to do that, which would be really difficult. But another thing that you could potentially be doing is looking at developing mathematical models to predict artificial roost or bat box temperature without ever having actually built that artificial roost to begin with. So this is an example of this Vielander et al. Paper where they did this for, I think they were working with martins in this case and building nest boxes, but you can actually assess the microclimate in relation to your specific weather if you know information about the volume of your structure and the thermal conductance of that material. Our lab, so my advisor, Dr. Joy O'Keefe, is actually working with Dr. George Bakken at Indiana State University to develop some mathematical models for our rocket box style artificial roosts that should be easily applicable and have some tools that are where you can just plug in your weather data for your local location to try to figure out what design of artificial roost or what color you should be painting that structure and get an idea of what the risk for overheating is in some of those cases. So super helpful tools here, and there's a lot of potential to refine these tools in the future and really apply them to bat box research. So another frontier, I think, is looking at the behavior of our bat species. So I really want to know what happens when bat box using bats or colonies of bats using bat boxes lose access to their bat boxes. So will these bats transition back to using their natural roost structures, or will they abandon that landscape entirely? So we want to avoid these situations where bats are entirely dependent on people for their future persistence on these landscapes. So it's something interesting to know, or it would be really useful to know for a conservation perspective, is that if bats do lose access to artificial roosts, for instance, if you lose funding to one of your projects, you can no longer maintain your field site, what's going to be the long-term outcome for those bats? We want to avoid something bad in that case. We also want to know what happens when you give nomadic species, for instance, the Indiana bat, a permanent roost structure that they're going to be using year after year after year. What does that do to their behavior and their social structure? So from some of our work at the Indianapolis airport, we know that our Indiana bats are actually forming larger colonies than they typically do in natural roost trees. They're actually staying put in those bat boxes much longer. They're not switching roosts as frequently as they normally do on a natural landscape. So that might relate to the ephemerality of those roosts. And in a lot of cases in these bat boxes, they can form much larger colonies than they can under peeling bark on dead trees. Then another question I had was looking at bats born in bat boxes. So will those bats preferentially select the bat boxes that they're familiar with over other alternatives? So this relates to the idea of natal habitat preference induction, where in individual animals, this has been demonstrated for a few bird species, perceive new habitats as potentially risky, will preferentially select something that they're familiar with over that newer alternative, even if that other alternative is actually better than what they're currently doing. They'll perceive it as being more dangerous because they don't have any information about it. And they'll stay in a suboptimal situation just because they perceive something else as being more dangerous. So we really don't know anything about bats and how they perceive the landscape in terms of will they stay where they're at? Will they still be really exploratory? And a lot of these things are likely to be species specific. So some bats might be really exploratory and not care and have no problem transitioning from bat boxes back to natural roosts. Other bats might be more hesitant to do so. So getting a lot of baseline information about all the different possibilities in terms of what bats are capable of doing will be really important for conservation work. Another thing is looking at landscape context. So how do predators respond to bat boxes, I think, is a pretty important thing. So bat boxes are oftentimes really conspicuous on the landscape, especially if you're deploying them on a pole out in a field or something like that. And you have a lot of really intelligent predators out there like raccoons, you have snakes, you have crows and things like that can be really interested in these structures. You can potentially subject bats to higher rates of predation if you're not careful about what's going on. So I know one study from Norway where crows actually figure out how to dislodge pups from artificial roosts in a town to be able to eat them. And essentially those crows were actually just crashing into this artificial roost. They would shake it and that would dislodge some pups that they could then eat. Another thing to think about also is looking at should you be putting bat boxes up on these highly degraded landscapes? So a lot of people want to put up bat boxes on these agricultural landscapes to try to benefit from pest suppression. But if you're doing that without reducing your pesticide, the amount of pesticides you're spraying on that landscape, is that really a good thing for those bats to be exposed to, right? We have some review papers out there that show all these horrible things that happens to bats when they get exposed to pesticides. So you could be setting them up to be in a really suboptimal landscape in some cases. But the other thing to think about is dietary needs of our bats. So we know that dietary diversity is going to be much lower on these agricultural landscapes. So essentially, do you want bats eating ramen noodles every day, or do you want them to have access to a more diverse diet if they had access to, forest fragments and things like that, where insect diversity is much higher? So a lot of things to potentially think about when we're putting up these artificial roosts. So should we try to restore these landscapes a little bit before we bring bats onto them? Do we wait entirely for that landscape to, develop and get trees and things like that, things that bats would naturally need to actually be in that area before we want to really attract them to that landscape, or potentially try to attract them to that landscape? But lastly, another thing that's really important here is expanding work to the global south. So a lot of these studies that I'm talking about today overwhelmingly come from Europe, North America, and Australia, and they're restricted to a handful of bat species. So we know a lot about the little brown bat, the Indiana bat, and the Bechstein's bat for the most part. And these species are not going to be, the responses of these species aren't indicative to the majority of bat species out there, right? It might be similar to a lot of insectivorous species, but there's a lot more bats out there that will be using artificial roosts that could have completely different responses that we aren't aware of at this point in time. So being able to generate more work in the global south, forming collaborations and building capacity to do that work in those areas is going to be really important going forward for bat conservation, since a lot of our species diversity is centered in those areas to begin with. But getting into the wrap up here, so I just wanted to mention a few highlights that I think highlight the overall value of bat box research. So from a lot of this research, we've gained really valuable insights into how bats are selecting a roost, understanding that a lot of these decisions they're making are based off of energy expenditure and trying to make situations better for themselves and their pups. We've also developed a better understanding of bat social interactions. So what cues do they find important? How are they sharing information with each other and things of that nature? And we've also developed in recent years a better understanding of the economic and ecological importance of our bats through the use of artificial roosts. So a lot of great work that can be done when you're using artificial roosts out here. And I think there'll be a lot more really awesome work done in the future too, as well, utilizing artificial roosts for bat research. But with that, I'm done here. I'll be happy to take any questions if y'all have any. Thank you so much for listening. I'll mute here, Dana, if I can. Hold on. Muted. Okay.
All right. So thank you so much to Reed. That was an absolutely excellent talk. I know, I feel like bat boxes are it's just one of those, bat boxes have been around for a while. However, I feel like a lot of the research is really starting to take off. So let's see if we have any questions. We have a question from Robert's iPhone.
Morning, Dana. Morning, Reed. Can you hear me okay? Okay. Great talk. I wanted to ask you, a lot of the bats that we're studying in bat houses, they've been around a lot longer than humans have been building bat boxes or human structures. I'm always concerned when I do a bit of studying of bats in bat houses as well, but I'm always concerned that we're creating structures that are either more available in the landscape in areas they wouldn't be spending time, or that we're creating structures that maybe their survival wouldn't be as high in if they had access to natural roosts. Do you have any insights on what's the comparative studies of what survival rates are in natural roosts, which are difficult to find, as compared to what you see in some of these bat boxes?
And I'm muted.
You're almost muted. Okay, there we go. Yeah, no, that was a very great question. And yeah, ideally, in a lot of cases, I see is that I would want bats using trees and use bat boxes as more of just a stopgap measure to get them to be using trees eventually. But unfortunately, we don't have great information on bat survival in roost trees at all. I'm not aware of really any studies looking at bat survival and reproductive success in trees compared to bat boxes, which is a huge gap in our knowledge. So we have no idea if these bat boxes that we're putting up are doing better than what bats would be doing in natural trees, just because it's so hard to study them. And that's not an excuse not to do that or to say that bat boxes are good, because we don't have that information. So I think it's really important to be looking at what's going on and try to figure out ways to do that. You could potentially look at things like genetic mark recapture, if you can do that and collect guano at all these different roost structures and try to get recaptures of individuals that way. But yeah, I also think like a lot of this research probably suffers from what they call like shifting baseline syndrome, where where especially in the United States, a lot of our forests are secondary growth forests, and we're using that as our baseline for comparison to artificial roosts, even though a lot of these forests would have been much older before European colonization, and bats would have had access to a very different types of trees on these landscapes. So it's very hard to know how bats are doing and what they're doing, but I think just acknowledging the context of the landscape and acknowledging that we're providing these different structures, these new structures that are ecologically very different from what's going on in trees is important to consider when we're thinking about bat conservation. So in a lot of cases, I think trees are the answer to bat conservation. Planting trees and putting them out represent a much more long-term solution than using bat boxes. But yeah, no, I think that's a great question. I don't necessarily have a great answer to it, but I think gaining a better understanding of bats and trees is incredibly important to what we're doing.
And we had a comment in the chat from Susan Holroyd calling in from Canada. Well done. I would just add to your value list. Our plan with the probiotic project is to use bat boxes as points of application for the probiotic.
Yeah.
And she also recommended Corey Olson's thesis that looked at reproduction in tree roosts. Do you know if any of his thesis work made it to journals, or is it all within the thesis?
Yeah, there is a paper.
I can always just reach out to Corey and tell him to send it to me.
Yeah, no, that'd be great if I could get that out. I haven't seen that yet, so that'd be super interesting to be able to get that.
It's a bit older now, but he didn't compare, of course. And I don't know if he's really got reproductive success, but it was related to the size of the cavity and how there was better reproduction in larger cavities. But so, yeah, but there is very few of those studies. So
Oh. Yeah, so that's a really good point. I think one of the other things that's really hard to think about with survival is like your bats might be reared successfully to volancy in your artificial roost, but then how do they fare during their first winter when they hibernate? So you could have a situation where a bat does successfully, essentially fledge and then go into hibernation. But if it's in a little bit worse body condition than it would otherwise be, how does that impact its first winter? Because that's a huge source of mortality for pups during their first years, making it through that first winter. So that'd be something interesting to try to study, is being able to get long-term data on this bat was successfully reared in an artificial roost and how well did it do that first winter? What were the fates of those bats, which would be very hard to do, but be super useful information to have.
You could compare like when the colonies
dispersed. From Robert.
Sorry.
Will you mute? Thank you.
Yeah.
Okay. I'll let Susan finish her thought.
Sorry, Susan. Will you say it again? I had my computer muted so that.
Oh yeah, sorry. No, I was just saying, like, if you wanted to look at that, you might not necessarily. Well, the long-term data would be great, but you could also look at the timing of parturition, and you could look at the timing of when those colonies disperse, because they usually break up when the pups start fledging. So you would expect earlier fledging bats that would probably go into hibernation at a higher weight because they have more time. So that's just one of the variables you could look at instead of. Yeah, because it's really hard to get that year-to-year data on weights and stuff. So,
yeah, it's a good idea. Robert?
Have you had much luck? I know that I've struggled with this, of getting an idea of what the roosting affinities are for male bats, as we tend to have more of a bias for these maternity colonies because there's access to a large number of individuals. But we don't often get to see the males again. At least we might see them as juveniles, but don't get to see them again for what their roosting affinities are. Any luck with some of the bat boxes you've seen and seeing males return?
No, so unfortunately for me, we also suffer from that bias where we're really focused on working with female bats, so we don't actually put any radio tags on our males to figure out where they're going or what they're doing. But in general, and this might vary from species to species, but a lot of our bats here in the more temperate climates are, matriarchal, and we really focus on protecting those maternity colonies, and we really view the roost selections of males as being much more flexible. Oftentimes we're thinking that males are going to be using much more torpor and forming these smaller groups. There's small bachelor colonies are roosting individually. It can be much more flexible in where they can roost. So that's why a lot of that research has been biased towards being more female focused, as their roost selection is more specific and much more vulnerable in terms of losing individuals if that roost structure is damaged or something like that. But no, I do think it's important to understand what male bats are doing and where they're going. And if we can get funding to do that type of work, that would be nice. But that's kind of hard to do for a lot of these bat species, since males aren't typically thought of as being all that important for the conservation of bats, since one male can mate with multiple females in a lot of cases with these bats, whereas the females can only rear one or two pups, depending on what species you're talking about, so per year. But no, that's a good question to think about. And I think for other bat species in other parts of the world, understanding the males is very important. So looking at species like the Florida bonneted bat, where the male is actually, forming a harem and defending that colony, understanding what those bats are doing and where they're going is really important. And how they're interacting with these artificial roosts is a really good question to be asking, I think. But yeah.
Yeah. And
Gosh, this is bad. We're lagging out.
Okay, cool. I know, from Alexandra in the chat, great talk, Reed, and says thank you. Did you experience any contamination from your diet samples for the guano trays? I'm muted.
Yeah, so that's a great question, and honestly don't have the answers to that work, since I don't really do that much work in terms of looking at like looking at the genomes and stuff in diet of bats. That was more of our postdoc, and I would collect guano for him. So that would be a question for him to ask, but I do imagine there's some level of contamination. So what we were trying to do is lay out fresh tarps every day and try to get individual samples when we could. So but yeah, no, definitely hard to do. And I bet that was something he was considering when he was doing that work. So unfortunately, I don't have a great answer for you there.
Thank you. Yeah. The pesticide and the degraded landscapes are a real issue if you have bat boxes in them. But yeah, I'll look out for the papers then. Thanks, Reed.
All right, do we have any more questions? All right, well, if not, we will go ahead and wrap up today. Again, thank you all so much for tuning in today and for asking some really great questions. And thank you to Reed. I'm going to gesture over this way because he's over there. So thank you to Reed for being our speaker today and for giving a really great talk. I think this is information that's useful, not just for us in bat research, but I think for anyone that's going to be setting up bat houses. So if you are someone that's working with the public, or if you do any kind of outreach, I think this information is really, really important to relate to the broader public, because the broader public is putting up bat houses. It's becoming more and more common. So using this information to make sure that we're putting up bat houses in informed ways, I think is essential moving forward for bats. Yeah, so thank you again to Reed. Thank you everyone for coming today, and stay tuned for next month's GBATnet webinar. So thank you so much, everyone, and have a great day.
Thank you all.
Bye.